Hi guys, today we're going to review some organic chemistry that you already know and add a little bit more onto it. So we're going to do a quick review. You can write this down or not, that's up to you. It's going to review everything you already know. So remember, just the basic definition of organic means that it has to have carbon and hydrogen. It could have other things, but it doesn't have to. We call it a hydrocarbon when it's only carbon and oxygen, so that's the difference, okay? The organic compounds that we know so far include alkanes. So remember, the ending of this matters, that it's ending in ane. So these compounds are hydrocarbons, but because it ends in ane, it only has single bonds. Okay? Because of those single bonds, that makes it saturated. The ending of any name that you give it will end in ane. Again, alkanes have to end in ane. For prefixes, that will come from the number of carbons. And so remember, we've got our trick of Maria eats peanut butter to remember these. And so 1 is meth, 2 is eth, 3 is prop, 4 is bute, and 5 is pent. From there, if you need a little bit more help with prefixes, you could check your Unit 5 packet. Oh, why did it do that? And those prefixes could be found on page 6 if you're not sure of some of the other ones. So we're going to make a foldable to talk about all of the other things that you know. So you've got this paper in front of you, and what I want you to do is fold it up. So take these edges right here and fold them in until it touches the line in the middle. And take this and fold it till it touches that line in the middle. So you should kind of end up with doors. The pictures will be on the inside, and you've got these flaps on the outside. Then what we're going to do is on the outside, we are going to write these words. Okay? So on the outside of your doors, you're going to put these words. So now what we're going to do is we're going to go inside each of these sections, and we are going to talk about what all of these different organic compounds are. So we're going to start with alkene first. So find where you have alkene. You should see a picture that looks like this. This thing is an alkene. Notice the ending of ene because it has a double bond between the carbons. So whenever you have an alkene, it's still a hydrocarbon, it still only has C and H, but now you have a double bond that we circled right there in that picture. Okay? Because of the double bond, that makes it unsaturated. The formula to figure out the hydrogens will be you take the carbon number and you'll just double it, so times 2. All of the names there will end in ene. Again, if it's an alkene, it must end in ene. Those endings will match. And so if you look at the example that we have, this is ethene. The eth is because it has 2 carbons. The ene is because it has that double bond. And notice that this follows our times 2 plus 2, or sorry, just the times 2 formula to figure out the hydrogens. Next we're going to go down to alkyne. Notice the ending is -ine here. And here what's special in this picture is the triple bond between the carbons. So what's going on here is it's still a hydrocarbon, still only C's and H's, but now you've got a triple bond in there. So that triple bond still makes it unsaturated. To figure out your hydrogens here, you're going to do times 2 minus 2. And any name that you put will end in -ine. The prefix will still be based on the number of carbons. So in this example, we have 2 carbons, which makes this ethine. Okay, so again, the -ine ending is from the triple bond. Eth happens because there are 2 carbons in there. And notice that the formula follows the times 2 minus 2, and that's why we have 2 hydrogens here. Okay, those are all the ones that you know. The rest of the ones on the foldable are new, so we're going to add these to your list of organic compounds. So go underneath alkyne, and we've got this thing called benzene. So notice this ending of ene means double bonds. And you see we've got some double bonds around in this ring. So we still only have carbon and hydrogen, but now they're appearing in this hexagon shape. And so these are all benzene, they're just different ways of drawing it. So all the things you need to know about benzene. It's still a hydrocarbon because we still only have C and H, but now it's in a ring shape, and that ring alternates where you've got single and double bonds going all the way around it. The formula for that is C6H6. If you go back up to your picture and you count, there's 1, 2, 3, 4, 5, 6 carbons, and 1, 2, 3, 4, 5, 6 hydrogens. So it's C6H6, and that's in all of the pictures, even though we don't always write the C's and H's. And the reason that benzene is important is it makes what's called aromatic compounds. Aromatic means smelly. So things like perfumes and anything that kind of smells good, we usually make that with benzene, and that's why it's such an important organic compound. Next we have alcohol, yes, like the drinking kind, but there's lots of other ones too. The functional group, which means the special part here, is this OH. So what alcohol means is that it's still hydrocarbon, it's got a C's and H, but now it has an OH attached. So that's the special part or the functional group of that organic compound. Okay? The names will end in "all," just like the word alcohol ends there. So that will match just like for the other ones. So in this example, this is ethanol. I said eth because it has 2 carbons, but then I added this ending of "all" because it is an alcohol, and the way that I know that is because that there's an OH attached. Another organic compound is called a carboxylic or organic acid. They'll use these two words interchangeably, so it kind of means the same thing. The special part or the functional group here is the COOH. So this is a super cool compound. Okay? Notice that there's a double bond here and then a single down here. But I look at the whole thing together for the COOH. So, a carboxylic or organic acid has a COO group attached. It's COOH. The ending for the words there would be oic acid. Again, that matches. Oic acid is just like carboxylic or organic acid. Okay? If we look at the example that we have, this is ethanoic acid. Eth means that it has 2 carbons. Right? There's 2 carbons in my picture up here. And I added this oic acid because the whole thing contains a COO group. Last one, we've got something called an amine. The functional or special group here is this NH. So an amine is any time that you have a nitrogen attached to some organic molecules. The names will literally end in amine, so that's a very easy one together. It matches the original name. So our example up at the top is ethylamine or ethanamine. It's the same thing. They both have eth. The reason that we have that eth is because there are 2 carbons. And the amine is in there because of the nitrogen that we have. All right, that's it. Now you're off to do a whole bunch of practice. Good luck.